Okay, for calc, we're going to continue using the unit circle, okay, but we might have to do a couple calculations in order to evaluate it. Okay, for example, we've got the sine of 45 times the cosine of 150. So to be good at this section, you're going to have to evaluate two things, okay, and what we're going to do is we're going to multiply these two ratios. So the sine of 45 degrees is right down the middle, okay, and the sine is the second value, and the sine at 45 degrees is radical 2 over 2. And now we have the cosine of 150. 150 is almost to 180, so it's down here. It's the low angle. The cosine is the first value. That first value down there is negative radical 3 over 2. And then what we have to do is multiply these. So it's definitely negative. A radical times a radical makes radical 6. Okay, so when you multiply fractions, you multiply across the top and you multiply across the bottom. The question is, can we cancel a radical number with a regular number? And the answer is no. We can't cancel these 2's. We can't cancel here, so this is our final answer. Next one, we've got two fractions that need to be added. Okay, so the first one is pi over 4. So if we go right down the middle, cosecant goes with sine. The sine value is radical 2 over 2. When I reciprocate that, that makes a radical 2. And now I need to add that to cosine for 3 pi over 2. 3 pi over 2, let's see, 1 out of 2, 2 out of 2, 3 out of 2. The cosine down there is the x value, and that is a 0. Oh, so this answer is just square root of 2. Number 3. This one has a little more calculation involved, so we've got 2. And then we're going to multiply the sine for pi over 6. So I'm just going to get some slots ready. Then we have 5 times that answer. Okay, so let's draw some doodles. Pi over 6. Pi over 6 is right here. It's the low one. And the sine is the second value, which is 1/2. 1/2. And then 11 pi over 6. Okay, let's see. 11 pi over 6 is not quite 12 out of 6, so it's going to be a little angle, and this, let's see, the cosine here is radical 3 over 2, the sine is negative 1/2, cotangent is cosine over sine, which is going to be negative radical 3. And now let's do some calculations. 2 times 1/2, that makes 1 minus, I'll multiply these, 5 times radical 3. You cannot add radicals to numbers. You just leave it like that. Okay, letter D. Let's go ahead and calculate two values, and this is a multiply problem. 120 degrees. 90, 120, that one's going to be up here. That's in the pi over 3 family. And the sine value right there is radical 3 over 2. Okay. And now 45 degrees, that's right down the middle. The cosine value there is radical 2 over 2. When you multiply fractions, we multiply across the top, make your radical 6 over 4. Let's do an adding one. So we're going to have a fraction plus a fraction. All right, 2 pi over 3. It's not 3 over 3, so it's going to be right here. It's the high angle, and the cosine is the x value. So what's the cosine for 2 pi over 3? It's going to be negative 1/2. And then 7 pi over 4. 4 out of 4, 5, 6, 7 out of 4 is in quadrant 4. The sine down here is negative radical 2 over 2. Okay, when you're adding fractions, you need to have common denominators, which I do. So the common denominator is 2. And the numerator is -1 minus radical 2. Cannot add numbers with radicals, so we'll just leave it like that. And the last one. Oh, this has some calculations. So 2 times the tangent answer plus 4 times this cosine answer. All right, let's see. Where is 3 pi? 3 pi. 1 pi, 2 pi, 3 pi. So we're due west. The point there is -1 comma 0. Tangent is sine over cosine. 0 divided by stuff is going to be 0. 5 pi over 3. See, 3 over 3. 5 out of 3 is down here. Cosine is this first value. And so that is +1/2. Okay, and now let's calculate. 0 plus half of 4. The answer is just a 2. Just a 2. Okay, so you have to be good at not only doing one value, but 2 values, and then maybe some calculations with it. Okay, the other thing we can do, okay, is use the fact that the unit circle is periodic. Okay, and what that means, okay, is you can rotate around and around. Okay, and we get the same values. We get the same values every time we circle around. Okay, so for example, if I have an angle of pi over 4, that set of coordinates, the sine and cosine, are going to be the same answers as if I swung round and round and around and then stopped in that same exact place. I'm going to get the same sine and cosine values if I stop in the same place. It's periodic. We keep getting the same ones over and over. Okay, so for example, to figure out the sine of 840 degrees, I have to figure out where that is. So how many times are we going to swing around? If I go all the way around, that's 360. So maybe what we could do here is figure out how many times 840. Let's see, if we take off 360, I could take off another 360. That's a full circle. Oops. So it looks like I can swing around another 360. Oh, but there's still 120 more degrees. So another 120 will take me up here. Okay, so I'm at the exact same place as 120. I just took the long way around. Okay, so when you're thinking up there, the y value is positive radical 3 over 2. Let's try another one. Where is 14 pi over 3? Okay, so the radian ones are actually easier. We don't have to subtract as much. Pi is 3 out of 3, plus another 3 is 6 out of 3. 7, 8, 9 out of 3. 10, 11, 12 out of 3. 13, 14. Okay, so we're at that high angle again, very similar to this one. Cosine value up here. Cosine value is -1/2. And finally, we're going to swing down -7 pi over 2. So this is -1 out of 2, 2 out of 2, 3 out of 2, 4, 5, 6, 7. -7 pi over 2 takes me right here. It's the same place as pi over 2. Okay, the point up there is 0, 1. So the tangent, which is sine over cosine, makes undefined. Okay, so I can use the unit circle to find exact values, either using the fact that it's periodic, okay, or possibly doing some calculations. Great job, pre-calc.